Welcome students. So today we are going to start a new chapter from class 9 physics, work and energy. And this is the first part of this chapter. So now work and energy while we talk about, okay. So there we described obviously the motions of the objects. Okay, before this work and energy we have talked about the motion, force and laws of motion and gravitation in the previous chapters, isn't it? So in work and energy also, while we do some work and when we get some energy to do that work, what we do, we should move that object. Okay, so there will be how we will describe the motions of the object and where if gravitation is responsible while doing the work, or while we get energy we do the work. Okay, so these type of small concepts we will talk about in this chapter. So let's start. First, there are examples of the work and energy. So this work, and here I have given the examples of energy. Okay, like in our all living things we need food, isn't it? We need food to live, and we also perform several basic activities. So see these basic activities. The first picture is what the children are playing, isn't it? They are doing some activities. Second is they are cycling. Some are cycling there. Then the third one girl is singing. Then a boy is studying. Okay, even a girl is thinking something. She has some thoughts in her mind, and a student is doing his homework or his work done. Okay, so these are what examples of energy that we need. These activities which we do day to day, we require some energy. Okay, so this is about human beings. Then of animals also there is. Let's see. In animals, what happened? The animals require this energy because they are too engaged in this type of activities. Regularly, they need this type of the energy. So what they do? They may jump, okay? They can run from their enemies. Then they carry the heavy loads, okay? Even for fighting also, they need the energy. And for finding their own food, okay, to feed themselves. And also to plow, means to pull the carts or plow the field. So these are types of the examples of energy these animals needed in their day-to-day activities. Mainly they need much more than us because their energy is totally physically, but our energy is mostly of mentally. We think something about mentally also. These examples are a view concept of energy. Now we'll talk about some work. Okay, let's see some work here. See here, this work, these are examples. I have given a work not done. But why not work done? We are doing some work. See, the children are studying there, they are doing some work. But in example from science, in scientific way, they are not doing any work. Like one student is drawing a picture of the structure of the plant. Okay, then the students are giving the exams, and on the fourth slide there the students are doing some practical in the laboratory. They are doing some practical work. So we think that they have the energy and they are doing some work manually. There means the student is studying, he is doing the work. But in scientific conception, this is not a work. Okay, they are not doing any types of work. Two more examples are see here. Here what is happening? Like you are trying to push. Okay, like you are doing one work that you are trying hard to push a huge rock. But despite all your effort and you're completely exhausted, what happened? No work has done. Means there is no displacement of that rock. You can't move even a single bit of that rock from the place. So here by science, this is not a work. Now, one laborer is taking means many this one a bag of like onions or potatoes in his head. He is tired. He is waiting for the truck. The truck will come and will take the this bags of the vegetables. But though he is tired, but science will say what? He is not doing any work because no displacement is there. Okay, so rude, no? Science is very rude to us, that it is said that no work you are doing here. But why? Now we'll see what examples of work done actually. Let's see here. See here, two pictures are shown there. One is that a father and a boy is climbing the staircase. Okay, like you are climbing the staircase to reach somewhere, and on the another hand, like you're playing, and suddenly you have to climb on a tree. Okay, so like you want to hide yourself in a hide and seek. You are playing, and you will hide yourself by means climbing on a tree. Okay, so here the science will say he is doing work, because there is a motion of the object, okay, or the body or the person, you can say. Okay, so let's get the idea very clearly here. This is one scientific conception of work. Two conditions needed to be satisfied for the work to be done. What are those conceptions? Mainly, number one, the force should act on an object. Whatever the force you will do, it should be there should be any action of that object, and the object must be displaced from its position. Okay, so these are the two reasons, two conditions that should be satisfied while we do some work. Now we will study about work done by a constant force. What happens when a constant force is there? Okay, so what happens, how work done we will find out. As this is a physics chapter, obviously there will be some mathematical value, isn't it? So let's start. See here, so here work done by a constant force, considering means let when the force is acting in the direction of displacement, means you have to move the object from one position to another. Let a constant force F acts on an object. Now see in the below, one orange color block is there, so there F force is given. Okay, this is a constant force, means you will displace the object from that position to the another position. Now let the object be displaced through distance s. The s is a distance displayed by the body in the direction of the force. In one side, means from left side to the right side, the box is displaced. Okay, so here W will be the work done. So W is defined, work is defined what? Be equal to the product of the force and displacement. How much force you have given and how much it is displaced, that is the work done. Thus work is said to be done when a force acts on a body, produces some displacement in it. So remember this all students, that W is equal to F into S, means work done is equal to the product of the force and the displacement. Now we'll get the idea of the work. So let's see here. Work done by a force acting on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of the force. So by a conceptual Simon's definition, or a scientific definition you can say, or a physicist definition, you have to write it this way. What do you mean by work done? That work done by a force acting on an object. Okay, that object you have seen, the displays of, isn't it? Work done by a force acting on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of the force. So work has only magnitude and no direction. Okay, now if F, now see here it is said work has only magnitude and no direction. Why it is said here? Distance is there, means where you are moving. But if you are moving like your friend is moving the object from left side to right side on the same distance, and you are moving from right to left side on the same distance, means there is no fixed direction. Okay, there is no fixed direction, so that it is said here it has only magnitude but no direction. There is no, it is not said that in this way only you have to move it. Okay, so If F is equal to 1 Newton, we know that force SI unit is 1 Newton and distance SI unit is meter. So S is taken as 1 meter, then W is equal to 1 Newton meter or 1 joule. So 1 joule is what? This is the definition of 1 joule. The amount of the work done on an object when a force of 1 Newton displaces it by 1 meter along the line of the action of the force. So this is the definition of 1 joule. So in this slide you have got the definition of work also and 1 joule also. Please note it down, students. Okay. So next we will talk about work only, but there will be some positive work and negative work. Let's see. No wasting time. See here. Work done here is what? Positive. Here see. Example is shown there. A cute baby is pulling a toy car parallel to the ground, where in that position she is walking and also she is pulling the toy car. So the baby has exerted a force in the direction of displacement of the car. In that way only, if she is moving to the north direction, she is pulling the car on her back, so that car is also moving in the north direction, isn't it? In this situation, the work done will be equal to the product of the force and displacement. So here work done, we know F into S. So force and displacement will be equal to the product of F into S. So in such situation, work done by the force is taken as positive. Here force is positive. Here W is equal to F into S. So we got here the idea of that work done is positive. But sometimes work done is negative also. So let's see here. So work done is negative. A man is pulling water from the well. Okay. So he is pulling water, bucket full of water from the well, and is applying the work upwards. As he is pulling, the bucket will come on the displacement will be upwards. The bucket will come upwards. So, but here will be another force. What force? A downward gravitational force is applied. Suddenly what happens if it slips from your hand? If the rope of the bucket slips from your hand, what will happen? It will fall on the down. It will fall through to the gravitational force of the earth, isn't it? So here there is also one downward gravitational force also that is applied, and that is the opposite to the displacement, isn't it? Isn't it opposite, you think? The man is pulling up, but one gravitational force is in the down, isn't it? So here the angle between the two directions is 180 degree. And in such situation, what happened? Work done by the force F is taken as negative and denoted by the forces W is equal to F into minus displacement. Here it is taken minus S, or W is equal to minus F into S. So here what happened? Work done is negative here. Now understood? Where we have got the idea of work done positive and how we use work done negative, isn't it? So here we will stop the chapter, students. So next part of the chapter we will study about energy. Okay, types of energy is there, energy is also there, okay, in this chapter. So till then, take care all of you. Bye bye.